Hi, it's Dr. Dave, and today's episode is how to test moderation using process. And so what we're going to do is we're going to use the latest version of process on one of the latest versions of SPSS. In order to get there, I'm going to demonstrate this using a file that I downloaded from the internet that I'm calling insurance or insurance charges. I have developed a little bit of some syntax to go along with that. You'll also want to make sure that you have that little blue SPD file from process to upload and to make process usable once you get there. So our starting point is to go to UTSA, UTSA My Apps, so that we can get SPSS. Go ahead and get in. Okay, so you should make it over to this page, and then we're going to upload our files. We're going to push that little tab, go over to transfer files. It says you can now upload files here by clicking on that. And then I want that insurance 2 file, insurance syntax, the process file. Once I have those in, I can close this tab. I can go to my file folder, go to documents. Where's it? Downloads. Documents. Go to documents, and then I can double click on the insurance 2. It should open up SPSS for me. There's my data set. Now this actually remembers that I have process, but I'm going to go ahead and, because I just did it earlier, but you'll probably not have that. So go to extensions, go to utilities, go to install custom dialog, then under documents, find the process.spd, open that, and there we go. So it's window, no, extensions, utilities, install custom dialog, then search for your document folder, find the blue process.spd, click on that, open it, and now when you go to analyze regression, you should see process 3.5 by Andrew Hayes there. So this version of insurance 2 that I have actually has more in it than what I was planning on starting you with. So I'm going to take a bunch of this stuff out. The original data set as I downloaded it basically had gender as a string variable, smoker as a string variable, and region as a string variable. So I wrote code. Did I write code? I wrote code to translate 2 of these into 1s and 0s, and then I just did copy and paste, sorting by region to give the regions 1, 2, 3, and 4. So let's take a look at this data set to see what we have here. So frequencies. So we have ages going from 18 to 64. We have males and females, they total 1338. We have BMIs that range from about 16, getting over into the obese at really obese at 53. We have number of children. There's 507, about 42% who have no children. So about almost 60%, 58% that have children, numbering 1 through 5. We have 79%, almost 80% who are non-smokers, 20% that are smokers, with 274 smokers. These people come from 4 regions of the U.S., Northeast, Northwest, Southeast, and Southwest. And we have the amount that they're being charged for medical care. And these charges are running from 1121. Now we're up into 7,000 something, 10, 11,000, up to 63,000 a year. I have to admit that what I don't know is to what extent this is for medical care received versus strictly the amount of insurance charges. I can assume that at least part of it is just insurance charges, because smokers are charged uniformly a lot more than are non-smokers. So you'll notice that I've recoded gender as zeros and ones, with ones being female, smokers as zeros, ones, with one being smokers, and the regions as 1 through 4, corresponding to the order in which we saw them previously, which I believe was Northeast, Northwest, Southeast, and then Southwest. I'm just going to go ahead and assume that's true, because I'm kind of tired of looking for it. Northeast, Northwest, Southeast, and Southwest. Okay, so that's what the data set looks like. What we wanted to test for was moderation here. And the advantage of process is that you don't have to construct all the interaction terms. I played around with constructing a lot of those interaction terms anyway, but let's just go ahead and jump in to see what kind of models that we can run and give you some examples. So let's start with a continuous by a continuous. So BMI is a continuous variable, and age is a continuous variable. So BMI and age, let's see if there's any kind of interaction effect occurring there. So we're going to go to Analyze, Process. Model 1 is for simple moderation models. And so I'm going to put in charges, the amount they're being charged for insurance as the Y variable. I'm going to put in age as my X, and I'm going to see to what extent that's modified by their BMI. The old version, you would stick it into M, and M served as the moderator or the mediator. The new version does not do that. So the new version, you basically are going to put the moderators always as W and Z. Up to you can only go up to 2 moderator variables to be analyzed. So that would give you up to a 3-way interaction. And so we have model 1, we have our moderator is BMI, our X variable predictor is age, and so we're going to go to options. We're going to ask it to show our code for visualizing the interactions. We're going to ask it for centering on any continuous variables that define the products. You'll notice that it gives you a couple of different options for the conditioning values. What I taught you was -1 standard deviation, +1 standard deviation, which would roughly be those percentiles. The percentiles are good for dealing with the possibility that you might not have a normal distribution. So it's always capturing at the 16th and the 84th percentile. I'm just going to go ahead and stick with the -1 to +1 standard deviation. That should do it. Hit OK. And here I see that there's no evidence of an interaction effect. Here I get a repeat of that. This is useful when you have multiple dummy codes. It serves as giving you the effect. What is called the unconditional interaction is basically the same as using the hierarchical sets as I taught. Here is our graph. Double click, highlight that, copy, file, open, the syntax window. Oops. Well, this is open that syntax window. Let's jump down to the bottom of it. Paste in that code for the graph. Highlight. There's the graph. Double click on the graph. Double click again. How about right click? Right click on the graph after it pops up. Hit properties windows. Go to variables. Element type. Stick in path. Then apply. And what we see there is absolutely no evidence of an interaction effect consistent with not getting an interaction effect. Okay. So let's do another analysis. Let's say this time we want to look at the interaction, let's say, between smoker and BMI. Smoker and BMI. So to do that, analyze, regression, process, model 1 to get a simple interaction. I'm going to take out age. I'm going to put in smoker as my moderating variable. It doesn't want the string variable, but I've already recoded it as zeros and ones under smokes. And then I'm going to put in BMI as my X variable. And options, generate code for visualizing the interaction. Still, I'm centering the continuous variable BMI, but it's not centering the 0 and 1 for smoker. This is probably not going to, shouldn't matter because there's only two slopes to be had, so I think it's going to not pay attention to that. Here's the output window. And what we see is that there is a significant effect for BMI. There's a strong effect for being a smoker. There is an interaction effect. And that is pretty hefty, accounting for 8% of the variance with 1 and 1334 degrees of freedom. Let's see if we can get a look-see at that. Grab the code. And let's get that syntax window. Put that in there. I can tell, looking at the syntax, you notice for smokes I have zeros and ones. So it disregarded the standard deviations. Oh, but it is taking care of the standard deviations. So it is going one standard deviation below, one standard deviation above on BMI, but on the dichotomous variable, it ignores the standard deviations and just does zeros and ones. Run that, we get our chart. Double click. Once you get the chart to come up, right click, properties window, variables, path, apply. And now you can see that as BMI goes up, if you're a smoker, the charges, insurance charges, are going up substantially. However, if you are not a smoker, the BMI is having a much reduced effect on the medical cost or insurance charges. Looking back at our process output, you notice that it gives the same standard model to start off with here as you get from a regression package, your multiple R squared, your standard estimate. It has the total model has 3 degrees of freedom. Here it's splitting it up into an effect for BMI, smoker, the interaction term. Down here you have these conditional effects, and it's showing you that for the smoker, as you go up for every 1 unit increase on BMI, you are getting an increase in cost of $1,473. So every unit up is having a pretty substantial increase, and that is highly significant. You still have a significant effect for the non-smokers, but you notice that it is $83 for increase for every unit up on the BMI. And really nice chart illustrating the effect. It's with the data centered, so at 0, this is the difference for people at the average on BMI that smoking is creating. And that would be reflected in the constant. So that constant of 84.35, be right here, 84.35 is the average amount that for people at the average of BMI who are non-smokers. Okay. Next, go back to the data set. Let's take something that's more complicated. Region has 4 different levels. And so if we wanted to dummy code that, here's the way that I laid that out as when I did a computation of dummy codes. So I basically said northeast, northwest, southeast, southwest. That was the ordering 1, 2, 3, and 4. And so I zeroed out southwest and I put in 1 for northeast, 1 for northwest, and 1 for southeast, and started everything off being computed to 0, and then basically specify that if region is 1, I make this a 1. If region is 2, then I make this a 1. If region is 3, then I make this value a 1. That gives me 1s and 0s for each one of my 3 demi-coded variables, demi-code 1, demi-code 2, demi-code 3. Okay, that's how I did it before I looked at how the program was going to do it. Let's see what the program does. Go to regression. So let's say that I want to look at region as my moderator, and my X variable, let's choose BMI. Okay. So I can tell you I've looked at the data, trying to make sense of it, and I'll note that that southeast region tends to be higher in BMI. So let's see what happens here and looking at the interaction effect. So this is not a 0 and 1. This is now not a continuous variables. It has 4 levels. When it has 4 levels, that's when we're going to specify it as multi-categorical. So we're going to basically say variable W is multi-categorical. Now we could treat X as region. That would be okay. And then we would end up specifying it as multi-categorical. It gives us choices of indicator systems, of coding systems. Indicator is a basic dummy coding system. Effects coding is effects coding. And Helmholtz is a specific type of contrast coding. And sequential is something I never mess with. It's a weird sort of dummy coding. I looked at it. I didn't really care to try and make sense of it. So regular dummy coding system is indicator. Effects coding system is a variant of the dummy code that returns, makes the constant equal to the grand mean. And Helmholtz is a default contrast coding system. Okay, so we're going to go with indicator. And then options, we're still doing only continuous variables that define the variables. Generated coding system, hit OK, and OK. And let's see what it's doing on output. And here we go. Now, first thing you'll notice is that it did a dummy coding system. I zeroed out the fourth region. It started by zeroing out the first region. So it did its dummy codes a little bit differently than I did. But you can tell it's a basic dummy coding system. It basically has three variables representing each of those regions. You'll see that for the most part, those are non-significant differences. Disadvantage here is it does not tell you what the effect is of region as a whole, so it doesn't give you a step-by-step where it tells you that W1, W2, and W3 together are significant or non-significant. It only gives you what the individuals are. It does, however, since it is focused on interactions, it does give you the test of the highest unconditional interaction. This is combining interaction 1, interaction 2, interaction 3. You'll notice it, you can tell that because it has 3 degrees of freedom. Each one of these by itself has only 1 degree of freedom. That's implied by the fact that it's doing t-test here, none of which are significant. And you see that, in fact, the interaction term as a whole is not significant. And so there's nothing really interesting to make out of this. Let's go ahead though and take and copy and paste and run and double click, right click, properties window, variables, path, apply. And what we see here is 4 different slopes. So one is a northeast region. 3 is the northwest region. You can see that the charges in the, no, sorry. 3 is the southeast region. So overall, south tends to be more expensive than west. South looks like it's more expensive than west, but I don't think that is statistically significant. You might be able to go in with a contrast code and find evidence of that being significant. You have that all the slopes look pretty much the same except for that southeast slope. It looks a little flatter, but again, it's non-significant, but just taking a little bit of time to interpret what's there just for the practice of interpreting. But so looks like as the BMIs go up, the cost is a little bit flatter, which is kind of interesting. So pretty cool. It works pretty easily to get those things. There's more that we can do here. Okay, so let's say that we wanted to look at see, let's keep region in there. Let's look at age. Let's control for smoking and control for number of children. And let's switch this around. We'll do a continuous variable, and then we'll look for a three-way interaction with that region variable. And what I have been doing is model 1, but what I'm going to do now is model 3, where I look for the three-way interaction. Model 2, you'll notice, is just looking at two-way interactions. Okay, so model 3, and Z is multi-categorical. Continuous variables. Let's see what happens. Well, this has generated a lot of interaction terms. So, and unfortunately, it only gives us the highest order one with the 3 degrees of freedom, showing that that is non-significant. So here it has as covariates, it's showing that, smoking is significant, the number of children is significant. Let's see. Interaction number 1 is just age and BMI. That is non-significant. Then it's showing that there is an effect for Z2. So one of the regions is higher than another. Well, it looks like there's another significant effect there. So that indicates that there's a little bit of a region effect, but we don't have a overall effect for region. We have interactions 2, 3, 4, let's see. 2, 3, and 4 is age by region. None of those individually are significant, so there's probably nothing going on there. BMI, 5, 6, 7, and 8 is BMI with region. And number 7 is just barely significant. And then our three-way interaction, nothing is significant. Let's take a look at this graph, though, that it produced for us. Uh-oh, wrong place. Copy the program it wrote into a syntax. I'm going to be really interested to see what it's come up with for us. Oh, look at how it broke this out. It basically stacked it in a panel form. so that you can see what's going on for region 1, region 2, region 3, region 4. Double click on that. Right click, Properties Windows, Variables, and Path, Apply. And there we go. And it's mostly straight lines because there really doesn't seem to be an interaction. Any differences seem to be kind of minor there. But you know, it's pretty cool to be able to grab that out for interpretation value. So fun. I hadn't done that before, the three-way. Now again, what I find disappointing there is that it doesn't give you the equivalent of the set regression. So let me try and repeat that same analysis here if I can remember what I did. I controlled for smoking and number of children, and I was focusing on age as the predictor, but then I put in BMI and region and then looked at the various possible interactions. So if I'm doing that by myself, I have to have demi-codes. So let me reproduce a dummy coding scheme. And then I had what I need to remember here. Age, BMI, and region. I've done region. So I'm going to center age equals age minus 31. I'm going to center BMI equals BMI minus 16. That seems okay. I found a couple of problems there. Back. So I again was using the data set that I generated based on looking at the graph, which is the reason why I got all those mistakes. And I went back to the syntax. I also had wrong values in there for centering. So average age is around 39. The average BMI is around 31. So have those centered. I'm going to compute age by BMI equals C age times C BMI. Okay, so now I have the continuous by continuous interaction. That's the easy part. Now, what I need to do is I need to take my dummy coding scheme and compute dum1 by age equals C age times dum in E. Compute dum2 by age equals C age times dum northwest. Compute dum3 by age equals C age times dum southeast. copy, paste, and now I have, let's see here, I want to change this to by BMI, so by B, change that to BMI. There we go. And now the three-way, compute three-way 1 equals C age times C BMI times dom NE. Copy, paste that twice, and three-way 2, three-way 3, dom northwest, and dom southeast, and execute. Let's try this again. I probably ran this on in the wrong spot. And so now when I run this, still have some mistakes there. Isn't it like a variable that begins with a 3? It does not. Okay. So that fixes that. So the variable should be in the data set. And so now, three-way interaction using set regression. So that analysis that we ran before controlled for smoking and controlled for number of children, I believe. We're looking at charges. Next, we're going to put in as predictors centered age and centered BMI. Next, we're going to put in our dummy codes for region. Next, we're going to put in our interaction, age by BMI. Next, we're going to put in the dummy codes by age. Next, we're going to put in the dummy codes by BMI. And last, we're going to put in the three-way interaction terms. We're going to make sure that we hit R squared change. And when we run this, in the end, this should match up with what we had from process. Let me check those three ways, crossing my fingers I didn't do something wrong here. We got 0.921, 0.124, and 0.162. Go back up, see if I can find process output. And I got the 0.92. I don't have exactly the same here. do I? And 4.01. And those were changed. Yeah, so something's a little tiny bit off. I don't know if I did a wrong variable in there someplace. But let me show you the advantage of going through it that way. The advantage is that I can say, okay, I can look for, there's a significant effect for smoking, significant effect for children. Then I got significant effect for age, significant effect for BMI. On the next step, I can say that the effect for region was marginal overall. So I don't really have to go into the specific predictors. Then I have here that there is the next one, age by BMI was not significant. I thought it was. Then there's no interaction between age and region. There's three variables representing that. No interaction between region and BMI, and there's no three-way interaction. So this allows me to basically assess by set so I can report it in analysis of variance fashion. And that is the advantage. The disadvantage was that I had to construct all of those codes. I had to do all the multiplications. And with a real complex model like this, I've also ended up with some little discrepancy here. Age, BMI, smoking, children, and age by BMI. Nope, it wasn't significant. Age by BMI wasn't significant. We did have what looked like an effect for region, but that ends up not being significant when you view it overall. And here there's a significant interaction 7. So one of the regions by BMI looks like it's significant, but analyzed as a set, we saw that that wasn't significant. The fact that we're seeing those overall as non-significant is kind of consistent with what we're seeing here, which is graphs that come out as looking non-significant. So that's it. That's the use of process for looking at interaction effects, going all the way to a three-way interaction. Hope you enjoyed and got something out of it. I'll try and go back and clean this up a little bit. Take care. Bye.